All right, so the next topic is the duality between confidence intervals and hypothesis tests. And this is basically going back to that example we had before with the balloon technique versus the surgery, right? We made a confidence interval for the balloon of 68 to about, I think, 87% success. And we knew that surgery had a success rate of 60%, right? And so we were able to say, okay, we know that the balloon is better than surgery because, well, surgery's success rate is below all the possible success rates for the balloon technique. So that same idea is what we're seeing here in this section. There's a duality. That the fact that we can estimate what the real P is means that we can also make some conclusions about real P. And to keep things simple, this is going to focus on a two-sided hypothesis test. So if we're doing a two-sided hypothesis test, essentially what's going to happen is if our interval contains P naught. So again, I'll rewrite that one example, right? We had an interval that was 0.68 to 0.87, and we had a P of 0.6 that we were testing. Since in this case it does not contain P, right? P was outside of it, we have evidence for the alternative. We have evidence that P doesn't equal 0.6 because we think P is somewhere between 0.68 and 0.87. So to me, this is intuitive. You shouldn't need to waste any note card space or memorize anything. But generally what you're thinking here is outside or does not contain is reject the null. If our value falls inside, then we're failing to reject the null. And there's also this idea that our confidence level and our alpha are complements of one another. And this is why we're focusing on the two-sided, because our confidence level is this middle percent, and then the outside would be our two-sided hypothesis test. So we're only looking at two-sided just for the simplicity of the fact that these two things will be complements of one another. All right, so our first exercise here says, according to the Society of HR Management, 19% of professionals are concerned with losing their jobs. Boom. So we have a P of 19%, which is according to some source. I don't like how this is turning out. And then suppose in a recent sample, so now we're getting some evidence, right, of 1,000 employees, 200 said that their biggest concern was losing their jobs. So our question here says, calculate a 95% confidence interval for the true population proportion of employees who are concerned with losing their jobs. So we have this claimed amount from the HR Management Society, but they didn't give us the sample size or anything that they used to get that, so we can't create a confidence interval with this. So we're obviously using the X and the N here. So either 1 prop Z interval, X of 200, N of 1,000, confidence level of 0.95, or using the formula P hat plus or minus Z star square root P hat Q hat all over N. This is all just 6.2 stuff. Either way, you should end up with 0.1752 to 0.2248. So we can conclude that with 95% confidence that the true population proportion of employees who are concerned about losing their job is between 17.5 and 22.5%. So the next question says, without conducting a hypothesis test, do you think there is evidence that the proportion of current employees who are concerned about losing their job is different? And here it should say something about the value claimed by the Society of HR Management. So they claimed basically, and we're not going to do a hypothesis test, that this proportion was 19. So the alternative to that would be that P does not equal, our true proportion does not equal 19. And so the question is, do we have evidence to support this? And that's why we're just going to look and see, is this value 19 in our interval? And this one does fall directly in our interval. So it is possible that P equals 14. We cannot prove that P doesn't equal 14. So no, there is not evidence that the proportion doesn't equal 0.19 because 0.19 is a possible value based on our confidence interval. Boom. So straightforward enough, right? So this question can get a little more difficult if I throw it into a multiple choice. So these next two multiple choice show you how I can make it a little more challenging. I urge you to try these on your own. Both of them just come down to this idea that we have the way to go back and forth between the two is outside is reject the null, which means inside is fail to reject, and our confidence level and our alpha are complements of one another. So hopefully you made an attempt at this by yourself. We do have stuff about hypotheses here. We're given step 1, and they also gave us p-value, or step 3. And then if we look at our actual statements down here at the bottom, every statement's about confidence intervals. So this is how I know this is a duality question, because we're mixing these two different ideas, 6.2 and 6.3. The easiest thing is to put these all in the same context, and I personally think hypothesis testing is a cleaner and easier context here. So I'm going to go through A, B, C, and I'm going to change all of these into hypothesis testing. So we know the confidence levels and the alphas are complements of one another. So this would have an alpha of 0.01, an alpha of 0.05, and an alpha of 0.10. And these all say will not include, which means every single one of these we're talking about outside or rejecting the null. So the question is just now, which of these actually would end up with us rejecting the null? And they gave us a p-value. So how does 0.06 compare to each of these alpha levels? Well, it's greater, so we'd fail to reject. It's greater, so we'd fail to reject. And oh, it's less. So we would reject the null. So C is the only one that actually makes sense here, because it's the only time that that p-value will be less than the alpha level of the corresponding hypothesis test. So again, if you didn't pause the video on that one, try out the next one. Again, it's just even more challenging. I'm just showing you how I can add like layers and layers onto this. All right, so the next one, we're given a confidence interval, right? And then it says we want to test the following. So again, we've got hypothesis testing and confidence intervals intermixed. And, well, we can go ahead and we can look and see 0.40, that would fall outside of our interval, so we would reject the null. And this is usually enough to answer most questions, unless I'm being tricky, as I am on this one. So we see here that we actually have two different answer choices that say we would reject. So we go, oh, but they have different alpha levels, right? We look back at this confidence or hypothesis test. These both have different alpha levels. So I'm going to convert them. What did I say? I said I'd like to convert everything to hypothesis testing. So in that case, I should maybe consider writing this as an alpha. It is possible to go the confidence interval way. It's a little more challenging in my opinion, but it is possible. You just have to think about which one's wider. So unfortunately, the alpha for the thing that we're talking about is neither of these. And C has the correct alpha, but it says the wrong decision. So this is why I said this one is particularly tricky. If we rejected the null, we do know something, right? We know our p-value must have been low because we rejected the ho. So our p-value must have been less than 5%. So if you're thinking about all the possible p-values, 0 up to 1 technically is the probability. We don't know exactly what our p-value is, but it's somewhere in this region. Well, if our alpha is 0.01, then we don't really know what's going to happen, right? The possible values were both above and below that. So this, I can't make a conclusion at. But 0.10, that's here. And any possible value, right? Anything in this area is less than 0.10. I'm basically making it easier to reject the null. So D is my correct answer, because if we were to reject the null at 0.05, we're still going to reject the null at 0.1. But like I said, there are some ways I can make these questions a little trickier and more challenging for the exam.